Hello, everyone. Welcome to this webinar on modern component design with Spring. You may be wondering what exactly we mean when we say modern component design. And let me put it like this. I'm taking the opportunity to present Spring's annotation-based component model to you in a slightly different way. We're looking at the overall model, the design of the model, the consistency of the model, the naming conventions in the model. We're looking at it from a design perspective with less emphasis on, the technical aspects of it all, less emphasis also on the Spring Framework versions that those things have been introduced in. We're basically looking at modern-day Spring in its full annotation-based glory. Well, not quite full. I'm not going to list each and every annotation that we're using to you. I'm going to focus on the most important ones, and I'm going to introduce a few bonus kind of options along the way. So it is a tour through this annotation-based model with quite a bit of personal preference in it, I openly admit. But at the same time, it's the way that we should be looking at Spring's component model these days, in particular if we're generally willing to consider the use of annotations, right? There's a wholly different way to use Spring, of course, but for today's purposes, we are looking at it from an annotation-based perspective. All right. Just a few words on myself. My name is Juergen Hoeller. I'm the Spring Framework project lead. I've been doing this for a long, long while, and I'm also in charge of the Spring Framework 4.0 iteration at the moment. So we're about to release Spring Framework 4.0 to the world, to you. We've actually released Candidate 1 coming up next week. I'll get back to that at the end. So there are also quite a few Spring Framework 4.0 features shining through. I might mention a few version numbers, even if this is actually not the main focus today. Okay. What are we going to talk about? What's actually the heart of Spring's component model? The idea is that we're starting basically with the core elements of the component model. That's like stereotypes, injection annotations, that sort of thing. I'll be spending quite a bit of time on the composable part, since this is actually, it's at the same time the most powerful and from my perspective also the most unique part, the way that we approach the use of custom annotations, basically composing custom annotations. We're going to look at factory methods and configuration classes, which is, of course, the meantime well-established feature in Spring's component model. However, there are quite a few little twists in there that may not be immediately obvious, and I'll point you to a few of those. And we're also going to see a nice 4.0 feature in there. Right. In the second part of this presentation, we're going to extend our perspective a bit. We're going to look at the Spring's controller style. So again, from a design perspective, right? Not from a getting started perspective, which is going to look at how does Spring's component model look like and feel like, both for MVC controllers with a REST focus, and also a brand new 4.0 thing, designing controllers for WebSocket endpoints. Again, very consistent style. We're going to get to it. And we're also going to look at declarative services. This is basically about the use of annotations for tapping into middleware services, declarative validation, declarative formatting, declarative scheduling, and declarative caching. So let's start the ride. To get it out of the way, basically, you need to bootstrap your annotated components at some point, right? Doesn't have to do much with design yet, but it's, of course, a step you have to take. Every framework has to bootstrap in some form and to find the components that it manages. That's the same with Spring. And with the Spring, we actually try to design it in a very usage-friendly way. It's kind of a what you define is what you get approach. So we're not doing anything automatically. We're not just searching the entire class path without you saying so. There's at least one instruction somewhere that kicks off any kind of search process in Spring. And in most cases, that's a component scan instruction. I'm sure most of you are aware that this is basically in the context namespace in the XML bin definition format, a single line component scan naming a base package or several base packages to scan as narrow as possible, ideally, so kind of narrow it down to the actual target packages in your application, ideally by prefixing it basically with the base package of your application, which makes the search more efficient. But what are we going to do then? We're going to find types by convention. Those conventions can be influenced through a filter model, but by default, we're looking for stereotyped components, basically components annotated with a Spring stereotype, with kind of the root stereotype being at components and quite a few more specific ones shipped with the framework, like at repository, at service, at configuration, at controller. And an important part being the composable stereotype model, which basically means you can create your own stereotypes. We'll find them by convention, right? There's no specific configuration necessary, even if you're using your own stereotypes. We're going to get to the stereotype building part. Compare this to JPA's approach. In JPA, you have a persistence XML file with a fixed location in meta-inf, but you do have an XML file, a concise one usually, kicking off a search process in the class path. In JPA, it's a little bit different because the search is actually within the jar file that persistence XML is in. So basically, the location of the persistence XML file identifies the part of the class path that needs to be searched. But that's really the only difference to Spring's approach. Instead of a jar file, we're using a base package as kind of the root of the search. Otherwise, JPA looks for annotated classes using an add-entity stereotype, which is JPA's own stereotype. All the classes annotated with add-entity are considered managed entity classes for JPA purposes. Same with Spring. All the annotated component classes, as explained before, all of those are going to be considered as managed beans in a Spring application context, in the Spring application context that contains the component scan instruction. That's a practical approach to do it. If you have no use of XML configuration anywhere, there is actually a more straightforward approach, and that is using annotation config application context, which is literally an application context implementation. Just new annotation config application context, and call scan or register methods on it. So you can basically instruct it to scan specific base packages. You can instruct it to register component classes by class reference, or also configuration classes by class reference. Those are var arg methods, so any number of base packages, any number of component classes, any number of configuration classes can be specified in one line. This is somewhat similar to JPA's listing of entity classes in persistence XML, where as an alternative to scanning the class path, you can just list entity classes by name, one by one. Annotation config application context is basically doing the same kind of thing. You register all the component classes that this application context is supposed to manage. Right. That's really all I meant to say about bootstrapping, because from this point onwards, we're within the annotation-based component model itself. We have a number, any number basically, of your choice of such component classes registered. The component classes express their fine-grained characteristics themselves. They basically say, I'm a service class. I'm not just any Java class. I'm a class with a specific purpose, with a specific role within the architecture, within the application's architecture, and it says so through this add service stereotype. It could also say add control, it could say add repository. This stereotype model at the class level, at the type level, is actually very similar in design, in spirit even, to the old UML stereotype model, if you may remember. Those UML stereotypes in UML diagrams served the same purpose, even used the same terminology in quite a few cases. In this case, of course, stereotypes have a very descriptive role, because what I was just explaining was basically a descriptive role. The class says something about itself in the source code. However, and this is very typical of Spring's use of annotations, we can also make good use of that information at runtime, where we say like, all right, by convention, any classes annotated with such a convention-based stereotype, add service included, can be detected by the very presence of that stereotype on that class, in the class part, right? So we kind of have annotations here with oftentimes two kinds of purposes in your wider development project. They have like a source level purpose. They tell you something about the class if you read the source code, and they have a runtime purpose. They allow a framework to react to their presence and to kind of infer characteristics from the presence of specific annotations. All right, that stereotypes up there. On the constructor, we have add-auto-wired, which is Spring's own injection annotation, the primary injection annotation. It marks, used on the constructor, it marks the constructor for use by the container, basically. If there's no more specific metadata presented anywhere, the container is going to use this constructor. Actually, it selects among all the annotated constructors, but usually it's one annotated constructor. And it tries to resolve the references that this constructor declares as parameters here. So in our case, it says like, okay, there's an account repository. My book admin service here wants an account repository instance. I'm going to resolve it for you. So the container basically goes searching for the account repository in its context. It selects an account repository even if there is more than one found. So it's the container's job to resolve the references for the constructor parameters here. Add-auto-wired can also be used on fields and on method parameters, so on like setter methods or the like. But in particular, it can also be used on fields. I'm not showing much of this usually, because like fields have a design issue. How do you set the fields and tests and so forth? But it can make sense, in particular with many references to be injected, and it's completely up to you basically. Another characteristic of Spring, we leave those choices entirely up to you. Whether you want to use constructor injection, setter injection, or field injection is entirely up to you. Okay, the third annotation here, add transactional, is a almost role model example for Spring's middleware integration for declarative services, basically triggered by annotations and leading to some kind of middleware interaction at runtime. Again, we have an annotation here called add transactional with basically two purposes in the system, right? Look at it from a pure readability perspective. The update book method here is transactional. This annotation tells you something about the methods that it annotates. And it's even named like that. You know, we named the annotation transactional. So we're basically even suggesting the descriptive part through the annotation name here. Compare it to transaction attribute or those kind of noun-oriented annotation names. Right. So it basically has a descriptive role, but at the same time, at runtime, the container can infer transaction boundaries, transaction demarcation rules from that annotation. So it basically says, okay, Without further information given, we basically begin an annotation before we invoke the update book implementation here, and we commit or roll it back afterwards based on some well-defined rules. All right, so that's three kinds of annotations here. Stereotypes up there, injection annotations on the constructor here, and declarative service annotations on our update book method here. We can take this quite a bit further, and I'm not going to go into too much detail on all of those, but just showing you basically 3 steps ahead in terms of the use of annotations. It's the same kind of class. It's actually the same class, right? But it has additional metadata expressed through annotations. It suggests a default scope session here, overriding the default scope, which is scope singleton, if not specified in Spring. It says at primary, which is a marker also found in the XML bin definition format. It says basically if somebody wants a book admin service by type, and I'm among the candidates, I win. I usually win it. Basically, without further information given, if there's more than one matching class to be found here, then this one basically is being selected among the candidates. This can be very, very useful, in particular if you're using a kind of decorator pattern or that sort of stuff within your architecture a lot. An interesting use of additional annotations can be found at the constructor level here. In addition to add auto-wired, we are also adding a qualifier annotation, which is the simplest possible form of qualifier here. Basically a string-based qualifier. It says qualifier production. So that applies to the dependencies expressed by the constructor. It says like, okay, this is account repository here. I basically want an account repository that is qualified with the label production, right? If there's more than one account repository, this can be very useful to select among several matches. If there are several implementations of the same interface in your architecture, but maybe in different slices of your system, right? Different parts of your system managed by the same application context, then you may use qualifiers to select among those. At this point, let me be clear about this. The class on the previous slide with just very simple use of annotations is much, much, much more common than the extensive use of annotations here. These additional annotations are there to support basically your needs if you actually run into them, if you actually have those needs. So you're only using qualifiers if you actually have to select among several matches. Otherwise, forget about qualifiers. You even can forget about primary, right? Those are basically features that are just there to express additional semantics for specific scenarios. The little lazy annotation here on the account repository is also interesting because by default, you're going to get a straight reference to the target account repository. That's what you get. That's what the container gives to you. This is even a Spring-based feature, right? You get access to the actual target instance. There is no in-between proxying unless you ask for it. There's also no lazy resolution to the target instance. However, lazy access to that target instance can be very useful, even necessary in some scenarios. And one way to express this is the use of @lazy here on the actual reference. So if you have several parameters listed here, you could only select one of them as lazy, for example. As an alternative, there you can also use stuff like the provider interface, and we're actually going to see this later on, but a nice annotation-based way to express this is @lazy. What you're going to get is a proxy implementing account repository lazily creating the target account repository implementation instance on access, basically on the first method invocation. It's going to create it. Right, and a few additional characteristics even found down there, like transactional has quite a few flags. We're not going through them here, but just two interesting ones. Read-only, true or false. It's actually false by default, but if you want it for descriptive purposes, you can even state it here. And you can associate a transaction-specific timeout at this level as well. So additional characteristics basically in almost all Spring annotations. At the same time, if you don't need more specific characteristics, it's going to look just like on the previous slide here, very, very straightforward. No additional fields unless you really need them. All right, let's go into composability. Composing stereotypes is one of the most powerful features in the annotation-based component model. Actually, composing custom annotations in general is one of the most powerful features, but stereotypes are the prime example. Look at this my service annotation here. This is actually the declaration of a custom annotation in your code base, right? You may not have done this before. You may touch such classes very rarely, but declaring your own annotation is actually a straightforward thing to do. So what you're seeing here is a my service annotation, custom my service annotation, meta annotated with quite a few characteristics that you're kind of combining into this custom annotation. You could also say it inherits those characteristics. But it's kind of a composability feature, right? It's combining several characteristics into one reusable annotation in your architecture. And in our case here, it says like, I share all the characteristics of a net service. I change the default scope to session. So anytime my service is being used, the default scope is session. I also inherit the primary characteristics. So anytime I'm used, I'm strong, right? I'm the primary candidate in a set of candidates if there is a set. And I even have default transactional characteristics. So by default, all my externally invoked methods are going to be wrapped with a transactional boundary, with a declarative transaction. And the declarative transaction even changes the rollback rule here. This is all being done kind of by default. So it's combined into the my service annotation. And every time you're saying at my service, like down below on my book admin service here, every time you're saying at my service, what you're actually saying is the combination of characteristics above. From that perspective, it's also a kind of shortcutting model. Instead of repeating all of those characteristics on every single class, on every single applicable class, right? You're combining it into a short annotation with a custom name, the name that you choose, and you just stick this short little annotation of yours onto all applicable classes, right? Onto all classes that are actually meant to have those characteristics. My service is now not the ideal name, right? I strongly recommend choosing a good name that tells you something about the role of those classes within your application architecture, like order service or account services, or if order and account maybe are modules in your system, or some kind of name that basically expresses the kind of classes that you're annotating with the annotation. Right, that basically is the composable stereotype model. Almost any annotation that you can stick onto the type level of a class can also be moved to this meta annotation level in a custom annotation of yours, and basically combined that way into a nice little shortcut. This model can be taken further. It's not just stereotypes, it's most types of annotations within Spring that can be customized that way. What we see here on this slide is a custom scoping annotation, my session scoped. Basically says, okay, I'm a custom scoping annotation. I declare a scope session with a specific proxy mode. So I'm proxying all the interfaces automatically. So any class annotated with at my session scoped is going to be managed basically as a scoped proxy instance in the container. Any access to it goes through a scoped proxy. If you know what a scoped proxy is, this can be very useful to define as a default, basically, in the form of a custom annotation here. The version below, the second version of my session scoped, even has a proxy mode field on it. It says my session scope, and it has an additional annotation attribute where it says like, okay, the proxy mode can be specified. It defaults to no proxy, Spring's default, raw access, straight access to the target instance. But if you want the default proxy, you can still specify it through a declaring that attribute. So anytime you're saying at my session scoped, you have the choice to say at my session scoped proxy mode equals something. So even overriding attributes from annotations that you inherit is possible. That's actually for row feature, a Spring for row feature. Just by convention, basically, if you're declaring an attribute of the same name in your custom annotation, it automatically overrides the same named attribute in all of the or in the applicable meta-annotated annotations. So if @scope up there has a proxy mode attribute, you may override it down here, which is a nice way to combine basically hard-coded characteristics like the session scope in this case with flexible characteristics such as the proxy mode, if you prefer to have it that way in your code base. The same kind of approach applied to transaction annotations can be very interesting as well. Standard approach is design a custom annotation, named myTransactional here. It's meta-annotated with @transactional, read-only false, timeout 10. Or maybe you want a different characteristic combined. You say my read-only transaction, and you meta-annotated with @transactional, read-only true. Maybe that name is too long for your purposes, right? And you just shorten it to @read-only tx, meta-annotated with @transactional, read-only true. The same overriding kind of approach can be used here as well. So if you want to leave the read-only choice up to the actual user of your custom annotation, just redeclare basically that attribute in your custom annotation. It automatically overrides the same named attribute in the standard @transactional annotation up there. So you have basically all the choices possible basically in designing your custom annotations. This is enormously powerful if you think about it. In particular, if you take into account that you can choose the names of those annotations. This can be used for guidance among a larger development team. It can be used for expressiveness in trying to make your source code more readable for the eyes of a specific audience even. So the combination of composing characteristics here and choosing a name for that annotation that combines those characteristics, that combination is very, very powerful. Let's move on to a related part of the core container model, of the core component model in Spring, and that's factory methods. You may know factory methods from configuration classes, and we're going to get to that in just a minute. But what we're seeing here is basically just raw use of factory methods. A factory method itself is just a method in one of your managed classes, one of your managed bean classes. But that method is not a regular method. It's a method meant to create a managed bean instance for the purposes of that instance to end up in the container, right? It basically creates an object for management by the Spring container, exposes an instance to the container for further management. The @bean annotation up there is the primary indicator that basically says, all right, this method here basically defines a bean, defines what Spring calls a bean definition. We derive a bean definition from it. The method name is the default bean name. It may have a few additional characteristics expressed through like @scope here or @primary here, just like on a regular component class that we find in the class path. We can use the same characteristics here. The main difference is we are not telling the container to construct an instance using the constructor, just the regular construction rules. We are telling it to use this factory method for constructing instances of that class, of that bean. And in this case, it's a session scoped bean. So every time we need to create a session scoped instance, basically once per session that actually needs that instance, we're going to see that factory method here being invoked. And the factory method can do anything it wants in its method body. It can use the constructor, it can call a couple of setters, or it can use some kind of custom service factory API, as you can see in the version down below. It is completely free to do whatever necessary to come up with an instance, an independent instance of this book admin service bean here. Right. I mean, that basically is the power of factory methods and the power of Spring's configuration class model. Basically, a lot of it comes from the factory method model here, is the flexibility in constructing the instances any way you want. It's, however, at the same time, it's even attractive if all you do is just to call the standard constructor, right? Just say return new bookadmin service impl or my bookadmin service. One line and you're done. Even that can be very nice, very concise, very straightforward, and very readable. And preferable to maybe component scanning, where you just find instances in the class path. You may prefer to have concrete factory methods for them for every single bean that you want to create it, right? From that perspective, it's even a kind of alternative to standard component scanning, where you're finding your target components in the class path and get standard constructors involved. In the context of a configuration class, as seen here, this makes even more sense, right? Configuration classes are basically classes where the entire purpose in life, right, is to have admin methods. Configuration classes actually are regularly managed component classes in the container technically and can be found that way, but their purpose is, their role is to have admin methods, any number of admin methods. This is kind of the unit of configuration that an XML configuration file was or is in the XML bean definition model, right? So it's very, very similar in nature. It groups a number of beans. It can have 50 bean definitions in here, or just 2. And you can have any number of configuration classes in your system, right? So it's also a unit of configuration that it's up to you to structure your bean definitions into those units. A special feature found in here in configuration classes is cross-references between factory methods. That's actually the notable because it's semantically interesting. If you look at the my bookadmin service method body here, it says service set data source, bookadmin data source. Then it points down to a bookadmin data source bean definition. It looks like a method invocation straight to that other factory method down there. But that's not quite what it is at runtime. The container is going to intercept that call and is going to route it through the container's instance management. So what you get is a managed instance of that bookadmin data source, which means if it's a singleton bean, you're always going to get the same instance. If it's decorated, if it's proxied with some aspects, then you get the decorated version of it. If it's scoped, then you get the proper scoping. So you get all the container services applied to it. And the container is just going to refer back to the bookadmin data source implementation here, to the other factory method, when it needs to create an actual new instance of that bean. So it's a kind of routing out to the container, and the container conditionally calls back into the bookadmin data source implementation. At runtime, that's the reason why configuration classes are actually CGlib subclasses. So we are using CGlib to do that method interception, in case you wondered why we are using CGlib, why you're seeing a CGlib instance in your debugger for your configuration classes. You're only going to get that behavior in classes annotated with add configuration. If you're using factory methods like add-bean methods in any other kind of managed component class, you're not going to get the CGlib subclass, and you're not going to get this interception of cross-method calls. That may be also worth mentioning, simply because in some cases you don't need that behavior and you prefer to avoid the CGlib restrictions. All right. Configuration classes are also a common place to use additional annotations on. So at the type level here, we see a profile being associated with this configuration class. Profiles, a Spring 3.1 feature, as a side note, but profiles basically associate a kind of condition with this configuration class. Only if this profile standalone is active at bootstrap time, when your application bootstraps, only then this configuration class is going to have effect, and only then all of its bean definitions are going to be registered with the container. There may be other configuration classes with other profiles associated, even with expressing alternative versions of the same beans. So profiles are basically a means to select different combinations of beans in your configuration. In Spring for the Door, we're taking this even further with a generalized programmatic condition model. So as a forward reference, there's even more power in there. But for simple declarative purposes, profiles may be all you need to express like the 3 or 4 different kind of flavors of your application that you may want to bootstrap. A general point, but a point that I find important to make is how do we actually match an injection point against factory methods? Well, it's very similar to how we match it against a regular target component class. But if you look at the example here, you basically see it in action. There's the book admin service again. It wants an account repository. It says, I want it with a qualifier production. Then basically break. Imagine that the admin method down there is in a different class, in some configuration class maybe. And it says, well, I create an account repository, and I do it. I create an instance that I want associated with the qualifier production. And this matching is going to happen by convention. If the container notices the method below, it registers a bean definition with that specified qualifier, and the injection point above, the constructor parameter there, is being matched against it. If there are other account repository instances with other qualifiers, no problem, this is going to be ignored. We're going to match by qualifier here. And so the use of qualifiers can be very straightforward, since it's basically the same annotation, the same piece of metadata that you're associating with the point where you need the object and the point where you build the object, right? So if you go through the source code, even if you search the source code, it's easy to correlate those, even in your mind, not just for the container, but also for basically us trying to comprehend how those things relate when we look through the source code. A nice little variant of this is matching by declared generic type. Imagine that you're designing components that use generics, right? Like a my repository interface maybe that uses a generic type variable and can be typed to account or a customer or like any type of managed instance that the repository is going to accept. If this looks like Spring Data JPA to you, that's kind of by design. So for those of you know, in the Spring Data extension project, this is a model found there. But it can also be used in your own design. Basically, just use a type variable, just declare it like that. We're also going to match this generic type information against the generic type information in target bean classes and in target factory methods. If you look at the factory method below, the factory method says I'm returning a my repository typed for account. Again, assuming that my repository has like a type variable T. This injection point above is going to be matched with the factory method below if there's no additional information given, simply by the use of the same generic type structure, of the same concrete type for the type variable. This is a Spring for the Door feature. Previously, we basically didn't look at the generic type information. We just matched by my repository here. You had to use qualifiers or something like that to select the one you wanted. Now it's actually sufficient to simply declare the generic type information accordingly. This would also work if you're using standard component scanning and if your target implementation class, like my account repository impl down there, if that class simply says implement my repository account, we're also going to detect this generic type information even in there. So if you have a regular component class implementing an interface with a specific generic type, we're going to find that information there as well. We're going to match it against the injection point up there as well. This is the For the Door feature. It's actually coming in For the Door RC1, so it's coming next week. Quick side reference. If you wonder how to integrate Spring expressions or like references to text-based configuration structures where you typically will use string expressions to refer to them, we have an add-value annotation. So in this little example here, the add-value annotation is going to be resolved. The expression in there is going to be resolved every time we're creating an instance of that bean. It's kind of an injection annotation, but it doesn't say match a target bean by type, which is what add-auto-wired does. It says please match, basically inject a piece of dereferenced information or a dereferenced object from some target structure expressed through an expression here. System properties.database name, that's just a string found in the system properties. System properties being a variable exposed by default here. But in the example down below, you can even say, I know that there's another bean called strategy bean in this application context here. And I don't want that strategy bean itself. I want its database key generator. So I want you to call get database key generator on it and to give me the result of this and pass it into this set key generator method here. This is a defaulting model. If there is external configuration information for the database name property, for the key generator property here, we're going to override. Only if there is no more specific configuration given, we're going to fall back to resolving these expressions here. This can be a very powerful element in your configuration approach. In particular, if you need a lot of access to more traditional text-based configuration structures. All right. For completeness kind of, let's revisit composable annotations again. We saw a few new annotations here, like add bean and add value. Those can be composed, as we learned before. All of them are composable, basically. So up there is a custom add myBean annotation that can be used on factory methods, adding a default session scope, adding a primary marker. Down there, just add value, as we've just seen. And in the middle, we have add-auto-wired associating a qualifier with the injection point by default, combining this into one annotation. If you look at the value example down below for a moment, and keeping the previous one in mind, instead of adding strings here, string expressions to your annotations, you can basically combine this into a type-safe annotation, custom annotation of yours, like my database name. Every time you're saying my database name, you're actually saying, I want system properties.database name resolved, that expression resolved. This can be a way to keep the injection points type safe, to avoid basically littering your code base with all sorts of string expressions. It only really works if you have a limited number of target properties that you refer to, but it can be one way to approach that problem. All right. To wrap that part up, we can also use standard annotations. Up until this point, what we've seen are Spring-specific annotations in Spring's configuration model. At the same time, we do support standard annotations. If you look at the examples here, all of them are standard annotations, and we can actually quickly forward refer to where they come from. So the inject annotation comes from JSR 330, so out of the Java community process. Transaction annotation comes out of JTA 1.2, the transaction annotation here. And the managed bean annotation comes out of JSR 250, which happens to be the same JSR that also defines the post-construct and pre-destroy annotations that you may know in the destroy method, if that rings a bell. So back to the example here. Basically, managed bean is a kind of simple stereotype, javax.annotation.managebean. Doesn't have composability of any kind, but it works for the simplest purposes. Add inject is an alternative to add-auto-wired, basically, marking injection points. Comes with a qualifier model, even comes with a kind of lazy access model. If you look at the use of the provider reference here, a provider for account repository, that's JSR 330's way of lazy access, of expressing lazy access. And edge transactional of course, looks exactly the same as the Spring transaction annotation, because in JTA, they simply, were influenced by Spring's design here. They use the same name, almost the same attributes. They just limited the number of attributes. There's no read-only flag there. but they have rollback rules very similar to Spring's annotation. So that's basically the use of standard annotations from JavaX packages. They are seamlessly supported. Just use them in your classes. Spring auto-detects them and automatically derives information from them. So there's no specific configuration necessary, just use them. The same applies to JPA support. JPA comes with a few rules of its own, of course, in how you get access to entity managers and so forth. Notice the use of the persistence context annotation here. Spring automatically resolves it, right? If annotation-based configuration is active, we also have the appropriate processing for the persistence context and persistence unit annotations active. Notice the use of the Spring transaction annotation down below, setting read-only flags here even. So there's nice interaction, seamless, straightforward interaction between even Spring's transactions, Spring transaction annotations and Spring's transaction processing with standard JPA entity manager access, even standard JPA entity manager injection. This is a dedicated goal in Spring's configuration model. If there are standard ways of doing things, standard third-party specifications for specific purposes, and those are a nice fit for Spring's model, we just seamlessly integrate them. No special configuration. They're supposed to feel like a natural part of the Spring component model, the Spring component story. That very much applies to JPA. It also applies to JSR 330, the aforementioned add-inject annotation, or JSR 303, the beam validation annotation, for example. Right. Here's just to have it stated, right? We don't strongly recommend specific annotations over the other. It's a choice that's up to you. If you're asking, we do recommend JSR 330 for dependency injection. It's for straightforward purposes. It's a very nice minimal specification, does exactly what it needs to do, has even a lazy access model, has a qualifier model. The one thing that it lacks, it has no composability. So you can't compose custom injection annotations with it. That's the one thing it cannot do. And actually, there's a second thing. You cannot express optional injection either. That's also something I thought to wipe clear. The use of JPA is, I think, very common anyway, right? And we definitely recommend it, even over native Hibernate access or the like in the meantime. So using JPA in combination with Spring's model feels very natural. Almost the same configuration approach. It's the same stereotyping idea. So if you like have a code base using Spring components and JPA entity classes, navigating between them, they just feel the same. They feel like they fit together, that they belong together. Right? Those models really feel like they are part of one larger component model. Right. Stereotypes and scoping, however, there's almost no alternative to Spring's model here. I mean, there is. You can use add managed bean, and there's limited scoping ways of doing scoping as well. But in general, don't dump your model down just for the purposes of using standard annotations. There's really so much power in the composable stereotype model and in Spring's flexible scoping model. By all means, basically use it, right? Make good use of that power. And that's why we definitely recommend the Spring stereotype model in this case. Right, let's move on to related areas. And I'm not going into details on those. I'm just going to show you how we apply these ideas and the use of special annotations, specific annotations, to other areas in the framework. This is a Spring MVC controller, using a controller stereotype up there, so it can be found in the class path and can be used as for all the purposes that Spring stereotypes can be used for. But it has a special way of expressing mapping rules for its handler methods, an at-request mapping annotation, binding, in this case, a URL subpath to a specific handler method. And those are just two examples, how you can apply those. Like the first one, the find book, is a nice example also for how we use parameter level annotations here. There's like an @path variable sitting next to this ID parameter. We're using this information to find out what you mean, like where's that ID supposed to come from. Path variable says it's a path variable. There's a same named path variable in my path, the ID in brackets up there. We're going to extract this value from there and to convert it to a WAM. There's also @request param, @request header, @cookie values. So you can extract information from quite a few request parts of the request structure. And parameter level annotations are the way to express this. If you wonder, how do we find out that it's the path variable ID? Well, in this example, we mean to read the parameter name. You can explicitly specify the name of the path variable if you want to, but by convention, if there's no special name given, we use the parameter name. In order to do that at runtime, we need to be able to read the parameter name. And there are simple rules associated to this. We're doing this in quite a few places, actually, where we support this for convenience purposes. If you're on Java 8 and you're using Spring 4, make sure you compile with -params. That's the Java 8 way of adding parameter names to the bytecode of your classes. Because by default, they're not going to be in there. By default, there are no parameter names in the bytecode for methods and constructors. But with -params, they are being added and can be read. On older JDKs or also on JDK 8, works there as well. You can also compile with -debug, which basically allows you to add debug symbols to your classes. And Spring is also able to infer the parameter names from those debug symbols. It basically happens almost automatically, right? There's no special setup necessary for this. Just stick to the rules, right? Compile with -params or -debug, and this is going to work. All right, a kind of related example where we are building a controller class that interacts with the STOMP protocol over a WebSocket. Subscribes to a STOMP event up there, or gets a trade request over a WebSocket down at the message mapping method, extracts some information, like in this case, the security principal and a trade object, converted from a JSON structure to this trade instance here. We're not going into details. My colleague Rosten has a really nice series of blog posts on exactly this WebSocket programming mod. Just basically find them on our blog, and we're going to do further blogging about it, I'm sure. But just from a design perspective, very similar. Controller stereotype, our annotated methods to be bound to specific events or specific messages. So we're applying a very consistent design vision to any kind of controller classes or endpoint classes that we have in Spring. This is a great example. It's a Spring 4.0 feature, of course, WebSocket support in general. So to complete the story here, we have model validation. That's basically integration with the bean validation specification with JSF 303. Which allows you to use JSF 303 constraint annotations like on your fields in your model classes, at not null, at parsed, or custom constraints that you built. Since in JSF 303, you can actually build custom constraints, custom annotations expressing constraints. Notice how similar this is to building custom stereotypes in Spring, or that kind of model. Right, and there's an example down here, which is a Spring MVC handler method, saying, okay, I'm basically mapped to a specific path, and I have an incoming data structure being bound to the book class here, to the book type, to the book instance. But I don't just want data binding, I want a validation step to occur before I receive the book object, before I get access to it. This little parameter annotation, add_valid here, says just that. Basically says, okay, book is not just being bound to, from a data binding perspective, populated with like fields, concrete field values. It's also running through the JSF 303 validator, and its results are going to be exposed as a binding result, declared right next to it here. That's if you want access to the results, right? If you don't care about the results, if you basically say it needs to be valid, and if it's not valid, I don't want it, right? Then just omit the binding result parameter, and it's going to fail basically before we even invoke the handler method. But if you want to evaluate the binding results, that's the way to do it here. That's JSR 303, right? Again, a nice fit with Spring's component model. Just use those constraint annotations in your model classes. They're going to feel very natural, sitting next to like JPA entity classes and Spring component classes. Spring doesn't come with its own set of validation annotations simply because we want those annotations to be standardized. We're talking about model classes, about like annotating a lot of fields in the heart of your domain model. Those really need to be standard annotations, in particular for several involved frameworks to basically consume them reliably. The persistence provide special web framework or web framework extensions, and Spring itself can all read the same annotations here since they're standardized. That's the greatest value of standard annotations. And that's why we're keen on having standard annotations here and did support them basically from day one onwards when JSR 303 was released. Okay. Adding to that model, we have custom declarative formatting options in Spring. So add datetime format is a Spring annotation where you can just, in addition to your constraints, express formatting rules or suggest default formatting rules more specifically. Just add a datetime format annotation with a specific format through a pattern or an ISO reference. And anytime this field is going to be rendered out in some text-based structure or bound to from a string, from an incoming string value, we're going to use this formatting rule to convert between like the string representation and the data representation. If there's no more specific information being given anywhere else, right? It's a kind of fallback, but can be very convenient and fits nicely next to constraint annotations. Datetime format specifically works for Java util date and calendar, but look at the example below. It also works for Java 8's new date and time types. In JSR 3.10, we have the java.time package, local date time, and so forth. More expressive, more specific ways of defining date and time types. We're supporting them in Spring 4, so just use them basically here, and Spring's formatting is going to apply to them just like it does to standard dates. We generally like the java.time approach, right? Java util date doesn't say much as a type. Is it like a plain date, or is it a date with time, or is it like a general timestamp or millisecond timestamp? What is it, right? It doesn't really say so. Whereas the java.time types in Java 8, they do quite specifically express what they are. A local date, a local time within a date, or a local date-time combination. They are very expressive from a typing perspective. And of course, they are a kind of standardization of Jodo time. And we did support Jodo time before. We still do support Jodo time now. And it has same named types, right? Local date, local time. You can also use Jodo time and use the types from there. It's all going to work from a Spring integration perspective here. Right. So to wrap this up, there's declarative scheduling. This is nice middleware integration, actually. If you want like implicit access to thread pools in your system where you say like on invocation of specific methods, I want those methods to basically be passed on, their execution to be passed on to some thread pool, there's a way to express this at async, an annotation that says like, okay, please intercept that method, wrap the target execution, pass it on to the configured thread pool. There's some backend configuration in Spring here. You need to specify a thread pool for this, basically. That's one point in your system. And then it's going to happen just by convention. Every time we find that async, we spin off. And you can either say, I don't care about the result, return type void, or you can even have a Java util concurrent future to track execution of that of the target method implementation. Right. And there's even a scheduling approach that way. If there's a backend thread pool associated with this, you can use add scheduled, just bind the cron expression to specific methods. Every time that cron trigger fires, that method is going to be invoked from a thread pool that you configured. So that thread pool, of course, can be carefully set up to be compliant with your runtime environment, as it usually does in Spring. So annotation-based ways to tap into asynchronous execution here. And there are even annotation-based ways to trigger caching, and that's what I'd like to end today's tour with. So we go even very much into middleware. Caching is a good example here, into middleware access, where you may specify all sorts of characteristics in the form of annotations, carefully named. I mean, look at that cacheable here. It basically says, this method does not require caching, but it is cacheable. It supports caching. You may wrap it and intercept it and cache its result, basically. By default, we're going to take the parameter, the incoming parameters, going to convert them to a cache key, and we're going to convert the returned object to cache the returned object for that cache key. But cacheable means if you're using it, please design your target implementation to also be usable without caching applied. So the annotations themselves describe those methods. They say these methods support caching. If caching is not active, no problem. If caching is active, Spring, that means if you use cache annotation driven or enable cache management once in your system and you activate caching that way, then those annotations are going to have runtime meaning. Then and only then. They're going to have runtime meaning. Spring is going to intercept those methods, going to apply caching rules to them. So much for this tour. We have seen quite a bit of stuff, and I had to select actually quite a bit. So there's actually more to discover. But I hope you've seen things that make sense for you, the problems that you face in practice. I hope that you've also seen things that you haven't seen before, since there's a lot in the Spring annotation-based component model that is yet to be discovered. There's a lot that we're adding to it as well. Quite a few 3.1, 3.2, 4.0 features that I've shown here. And there's just a lot of power in the very overall design here. So the most important point to make here is there's a lot of consistency to our use of annotations, to our naming of annotations, even to our use of third-party annotations like JPA, JSF30, JSF3 beam validation. Those things really all fit together very nicely in Spring style. So there's still explicit but very convenient configuration in Spring. So at the heart, it's an annotation-based component model. Around it, there is a runtime container that can be carefully instructed to process things the way you want them to be processed at runtime. So, of course, all of those good Spring characteristics are being preserved. All right, and let me just state again that we have Spring Framework 4.0 release candidate 1 coming up next week. So the Spring Framework 4.0 has been in the works for a while. I've mentioned that there's Java 8 support in there, there's WebSocket support in there, there's a few things that I've mentioned, like overriding annotations in Composable, overriding attributes in Composable annotations. That's a 4.0 feature. And a few other things. Generics-based matching is also in there. So that's coming up next week, and we're going to go final in December. So it's not far off. First release candidate, I'm sure there's going to be a second one, but expect this to be final towards mid-December. And yeah, thanks for joining the tour. There's a lot that I've been pointing to, so I hope you enjoy finding out more about it. But there's even more to find out, right? There's always more to find out. And with Spring, we have very interesting new initiatives. If you like what you've seen here, check out Spring Boot, for example, the new Spring Boot project. It does great things based on the Spring 4 annotation-based component model. We have a brand new website for a start, spring.io, complete relaunch of our web properties. It's actually a Spring-based application running our website now. So we're eating our own dog food even through our website, and I hope that the user experience is also in a wholly different league now. So definitely check out our new website, spring.io. A lot of good stuff on there, very different from the previous website as well. And of course, we have quite a few channels where you may want to get our updates from, like the Spring Central Twitter account, or we have a YouTube channel where we are publishing all those webinars and quite a bit more on YouTube. And last but not least, we have a show in London coming up. So if you're in the London area or have easy access to London, in mid-November, we have the Spring Exchange, a 2-day conference coming up in London. Quite a few well-known Spring speakers there, myself included. So if you're near London, definitely consider going there. There are not that many opportunities actually to get such a combination of speakers from us in Europe these days. Okay, once again, thanks for your attention, and I may select a few questions now from the Q&A. So yes,
Juergen, I can tee them up for you. I've got a couple from the Q&A right here. So Cyril Deba asks, if @AutoWired could be replaced by @Resource, correct? Do you prefer @AutoWired only because it comes from Spring, or is there some other reason?
That's a good question. @Resource, actually not shown here, is an injection annotation coming from JSR 250 back in the E5 days. We are supporting it, so you may use it, but it's semantically different from @AutoWired. So if you look at @Resource, a resource is basically a name-based lookup into some target like naming system. It's meant for JNDI. We are translating it to Spring-based access, so Spring bean names, lookup by bean name. If the @Resource doesn't specify a name, then it falls back to the field name or the bean property name of the setter that it annotates. So it basically has kind of naming rules associated with its lookup. And @AutoWired is a type-based and qualifier-based lookup. So it's semantically different. As a standard annotation, @inject, like shown in JSR 330, the @inject annotation is almost identical to Spring @AutoWired. So if you basically want a standard version of @AutoWired, use @inject. @Resource is a little bit different, can actually make sense to use it if you're primarily looking up by name and want basically no other rules applied, then it's a good way to express that. But if you want the more generally applied type-based lookup, use @inject or Spring @AutoWired.
The same person, Cyril, asks, is the WebSocket protocol has a number of different revisions and it affects compatibility. How are things going in Spring? Is it more of an experimental feature, or is it closer, getting closer to being production ready?
Yeah, that's again a great question, because the reason why we have been waiting actually with our WebSocket efforts is exactly that, right? The WebSockets had to mature, and the industry generally was very willing to kind of consider it from early on, but we haven't seen much use in production. We actually start seeing use in production now, or at least strong consideration for use in production. So I think our timing to do WebSocket support is just about right, where things are mature enough, agreed on enough to be supported in a more industry-wide fashion. Of course, we can't do much about the general constraints of using WebSockets, like primarily used within your network and so forth. But we are doing the best we can to make it as convenient as possible to bind endpoints to a WebSocket, to support messaging protocols over a WebSocket. So what we're doing here is very practically driven, and we're trying to be as industry standards-based as possible, but not limiting ourselves to plain WebSockets. We are also supporting industry-accepted protocols on top of WebSockets, such as the STOMP messaging protocol. That is actually a very important part of our story. Raw WebSockets, that's not very practical, right? It's more interesting what do you do on top of WebSockets. And we have a strong messaging story. Wasn't the focus of today's presentation, but there's a lot to discover there. We have a completely new Spring messaging module being supported in the next generation of Spring integration, also being supported by our WebSocket endpoints. Check out Russell's blog posts if you'd like to learn more about it. There's a lot of good content in there.
I actually just linked the person to both of those blog posts.
That's great.
No problem. I'm probably not going to pronounce the name right, but Yukun Ma asks, the behaviors behind the annotations have become more and more complicated and been used more and more extensively, while the exact nature of these behaviors are not always clear to each developer. Should we concern the debugging complicity here? I'm not quite sure what that means, but
yeah, I think I know what it's where the question is getting at. There's quite a bit of truth in it, right? It's of course the rules behind annotation-based processing are not always very obvious, kind of by design. Like this entire industry is focusing now on more implicit ways to express what you want. Basically, declarative annotations and some runtime behavior derived from it. We are trying to have very straightforward rules applied to it. So in general, the rules are straightforward and hopefully reasonably well documented. If you're trying to debug what's happening, even that should actually be quite straightforward with Spring. So we are trying to keep things simple enough for you to be able to track them in the debugger. I mean, you need to be willing to expose yourself to some framework internal structures, of course. But Spring is an open source framework, right? We're not trying to hide the implementation from you. An important part in Spring is that we are based on one implementation, right? If you're using Spring's component model, you're shipping the Spring container with it. In your application, there is a definitive single implementation executing your components, right? Hosting your components at runtime. So if you're debugging it, or if you're customizing it or tweaking it, you know exactly which runtime framework, which runtime container implementation you're running against. I personally think that this is actually an asset in its own right. It's an important characteristic of Spring in its own right. Whereas, with a standardized approach, you have a spec that you're using and a runtime implementation that you don't know, where behavior may differ. And in Spring, at least, the behavior is well defined simply through the implementation and the implementation's documentation, the single implementation that you're running against.
Thanks, Juergen.
I wouldn't be too concerned, but it's true that debugging got a little bit more complicated in recent years. Okay, next question.
Yeah, sure. Yeah. So this one you may actually want to look at the. There's one of them you may want to actually look at the question chat because he's writing in some code here in the form. It probably doesn't lend itself to being verbally translated. But while you're pulling up the question queue, I'll pull one other. Barbara asks, are the @valid, @async, and @scheduled annotations and @cacheable, are those four annotations, are they Spring 4 features or are they coming from earlier versions of Spring?
I figured that in particular the pre-4 nature of features might be important to quite a few people. Yes, all of them are supported in Spring 3.2. So even in 3.1, if I'm not mistaken here. So definitely use them against Spring 3.2 here. They are all going to be supported just fine. However, generally speaking, I strongly recommend an upgrade to Spring Framework 4 once we ship it. It's a very straightforward upgrade from 3.2. We almost released the Spring Framework 3.2 generation primarily for it to be a straightforward upgrade to 4.0. So don't be afraid of the upgrade once it comes. It's backward compatible to JDK 6 and Java EE 6 and higher. So you shouldn't really hit any wall in your upgrade path here. So that just as a related note on general upgrades. We designed Spring Framework 4.0 to be very immediately and commonly usable in today's world, and to be a straightforward upgrade from 3.0 once again. From 3.2, sorry. Okay.
No problem. Next question from Thomas Inman. Do you prefer @value setters over an @postconstruct block? If so, why? Again, the question was, do you prefer an @value setter over an @postconstruct block?
Construct block. That's an interesting question, which I haven't actually thought about that much before. Of course, you can do a lot of things in a post-construct block. It's just a little like in an init method implementation. It's just a little hard to express the defaulting characteristics that way, where you're basically saying something like I have a setter here for an independent setter for a specific property. There may be an external value passed into that setter, but maybe not. Then I'm falling back to this expression. You can't express that very straightforwardly in an init method. I mean, you can, but it's a bunch of if-else blocks at that point. And I find it more elegant, actually, if you actually have such a situation. I find it more elegant to use @value for it. But don't be afraid of init method, post-construct methods either, right? I mean, those things, if it works for you, it's all fine. If you have special data structures to extract that information from, then the best place to do it is a constructor implementation or a post-constructor, like an init method implementation, right? So it's definitely features that kind of complement each other. But for these defaulting characteristics, I generally recommend @value if its characteristics are a good fit with what you're doing.
Okay, let's see. I think we've only got a couple more questions here, Juergen. Thank you.
Sure.
Another WebSockets question, so I'm going to wait on that for 1 second. Angel Pereira asks, which is better, an auto-wired constructor or multiple auto-wired attributes?
And I suppose attributes are translated to fields, to instance fields. It's a bit of a design question. I'm a great fan of constructors and of using constructor arguments for what they are meant to be used for. But if you have, in particular, if you have a high number of values of references to refer to, then a constructor with 6 or 7 parameters doesn't look that great either anymore. And then maybe breaking it down to setter methods or to what we call configuration methods, which is like a setter method with potentially more than one parameter. Breaking it down a little into several injection points may be a good idea. Or field injection, right? There are really no strong rules associated with it. I've seen a lot of use of field injection in test scenarios, but also in production code, and it works just fine. And in many ways, it's a straightforward thing to do, commonly accepted these days. Even with private fields maybe not being immediately accessible any other way. From an architectural perspective, I generally like to design my component classes in a way where there are public ways of passing things in. So you may theoretically also combine a public constructor that's not annotated with fields that are annotated, so you can still override it in other scenarios. So it's a matter of preference at some point. I don't have a strong opinion on it, but for simple enough scenarios, I would recommend going with constructors first. 2 or 3 parameters, or even just one. Constructors are a great way to express this, and a great way to suggest programmatic use at the same time.
Excellent. Thanks, Juergen. Okay, another WebSocket question from Marcus Crow. Is WebSockets meant as subscribe only, or can you do WebSockets via @async?
Those features are, at the moment, they are not related, right? So the WebSocket endpoint model is based on subscriptions and based on incoming requests, incoming messages. The async feature is independent from that, and it's basically an invocation-driven feature. They can be combined, but they don't interact directly, right? You may have a WebSocket endpoint accepting a message and firing off a processing of that message through an async method, which basically means it may return immediately, send a acceptance notice back to the a message back over the channel while the execution is going on in some background thread. So they don't conflict with each other. but conceptually they are independent features with independent characteristics.
Excellent. All right, thanks. All right, I think we're almost at the end of the question queue here. Let's see, Juergen. There's one that from a gentleman named Dezanis. It's a bit of a code snippet, so it's kind of hard to read and didn't lend itself to verbally repeating. So I don't know if you happen to have the Q&A.
Yeah,
if you want to check it out.
Yeah.
Okay.
It's not. Yeah, the formatting doesn't help exactly, but I'm trying to understand what it's about.
Maybe let's save that one to the end, or maybe what we can do is, Dezanis, if you're still on the line, why don't you just tweet that to us at Spring Central, and we'll
maybe
go
better,
from
because
there.
I think it's also hard to explain otherwise. I think I can kind of infer what you're trying to design here, but yeah.
He or she is still on the line, so he's hearing me.
Okay, yeah. Please send it to us on another channel. That would be great.
Yep.
Okay. Can we one more? Maybe that's.
Yeah, we're almost there. Let's see. Do you want one on an @schedule annotation, or do you want one on annotation and performance in like a Google App Engine world? What sounds more interesting?
Yeah, we can quickly go through that. Google App Engine is an interesting scenario because the runtime environment has so many special rules, including a hard limit on startup time for a given deployment unit. We are aware of those characteristics of Google App Engine. We're actually working with the Google App Engine team even directly in trying to find ways to design a Spring-based deployment unit in a more Google App Engine friendly way, which primarily means cutting down on startup time. The one thing that annotations also kind of imply are somewhat increased startup time. At the moment, the simplest possible answer, the simplest possible solution to that problem is try to avoid component scanning. That's generally limiting component scanning to the target packages where something can actually be found is a good idea in general. But on Google App Engine, due to its security manager, even looking at class files in only a part of the class path can be expensive. So I would try, if you can, to avoid component scanning altogether. The alternatives would be register your component classes by class reference. I've shown this quickly, the annotation from Fig Application Comics. Basically say register and just enumerate the classes as class references. Even if you have 50 classes or 100 classes, it's not as bad as it sounds. You can enumerate them quite easily. It's just the classes, comma, class, comma, class, comma, class. Or in an XML bean definition file, the equivalent would be do like a bean element with just a class name, one line, bean class, bean class, bean class. No names given, no additional field set, just one line bean class. Even 100 beans can be defined somewhat straightforwardly that way. That avoids the problem of trying to having to introspect classes in the class path. And that almost removes the problem entirely if you're running on Google App Engine. We're trying to improve the performance of component scanning on App Engine, but it's not as straightforward as it may, as you might think. So before that happens, I would just recommend avoiding component scanning as explained.
Yep. Juergen, thank you so much for your time. Really appreciate it. And just want to let everyone know on the phone that this webinar is being recorded and will be available at spring.io/video, which is a shortcut to our YouTube channel. If you'd like to be notified of the replay's publication, you can simply subscribe to the Atom RSS feeds at spring.io. Because we post those announcements and the embedded videos to the blog. Alternatively, if you're more of a YouTube fan, you can subscribe to our YouTube channel. I just want to mention again that Juergen is going to be at the Spring Exchange in London on November 14th, 15th, with a number of other really of our best speakers from engineering. So if you're in the Greater London area, or maybe even just sort of in that region and in that area, you may want to go check out the Spring Exchange event. And again, that's spelled EXCHANGE, Spring Exchange. That's November 14th and 15th. Also, later on, let's see, we've got a bunch of exciting webinars coming right up. So please join us again. Next up, we're going to be, we just posted the replay for WebSocket browser applications. We also posted the Day 2 keynote from Spring 1.2GX 2013. A little later this month, on the 19th and 21st, you're going to see Josh Long and one of our partners from C24, John Davies, talking about doing dynamic routing of 1 million messages per second with Spring integration. And then on November 21st, Josh Long is going to be introducing just everything that's been happening in Spring lately. There's been a lot of new stuff that you've heard not only from Juergen in Spring Framework 4.0, but things like Spring Boot, Spring XD, lots of new projects and new life happening in the Spring ecosystem. So Josh Long is going to give us kind of a whirlwind tour of the Spring you thought you might know, and that's on November 21st. So look forward to seeing you on those. Juergen, thanks a lot for your time. Is there anything else you want to say?
It was my pleasure.
To wrap up the webinar?
Well, other than thanks everyone for staying on so long, even for the Q&A section. I really appreciate the questions and the feedback. Keep it coming, and definitely check out Spring Framework 4.0 as we enter our release candidate phase here. It's a great time to provide feedback to us up until December.
Thanks so much. Take care, everyone. Have a great day.
Cheers.